The first one, if you go left to right, this point here is -3, -2. This point is +2, 3. So going left to right, there aren't arrows on this. This is just a line segment. And it goes from -3 for x to +2. That's the domain, side to side. So we write this as an interval that goes from -3 to +2. If we look at the range is going up and down. -2 is the lowest point, and +3 is the highest point. So going up and down, this goes between a -2 and a +3 inclusive. Okay, let's look at the next one. This is a split function, and this point here is, just to be clear, -2, -2. This point is the point, well, it should be 1, 5. This is the point 1, 2, but it doesn't include that point. That's why it's an open circle. This is 1, -4, and then it's a constant function from there over. So what is the domain side to side? The domain is going to go from -2, and then even at 1, it is defined. It's open here, but it is defined down here. So it's going to go from -2 all the way to the right. So it would be inclusive of -2 and go to infinity. The up and down value. -4 is a solution up to 5. So now but it's not continuous. -4 is a solution in and of itself. Just that one value. So -4 is a solution. And then we've got the other part of the graph that goes from a -2 up to 5. So we're taking a look at just the point the y value -4, and then here a y value of -2 up to a y value of +5. So we're defining domain and range that way. Any questions on looking at domain and range graphically? We looked at them algebraically.
What do those other brackets mean? Like that you have
It
around the
means
-4.
that it includes the point -4, just the y value -4,
Okay.
or the interval for y between -2 and 5.
Okay.
Okay, I want to look at 3 different equations. The first is just a line. If we write it as y equals mx plus b, we get y equals -x plus 4. If you want to even look at it that way. Slope would be -1, y-intercept is 4. This does pass the vertical line test if you wanted to graph it, so therefore it does define a function. So we also need to look at, if we put in an x value, do we get multiple y values? So if for y equals 1 over x squared, if we, for example, put in 2 for x, we get y to be 1/4. If we put in -2, we also get y to be 1/4. Now it's okay that 2 is mapped to 1/4 and -2 is mapped to 1/4. We just can't have an x like 2 going to 2 y values. So this also does define a function. If we look at y equals x squared, I have a number of different points here that work. If I put in 2 for x, then I have 2 squared, and 2 works because 2 squared for x and 2 squared for y both give me 4. If I have 2 and -2, that works because x squared equals y squared. If I have negative 2, 2, and if I have negative 2, negative 2, they work. So for a particular x, like 2, we get two different y values. Or for negative 2 map to 2 and negative 2 map to negative 2, this does not define a function. Because for a particular x value, there can only be exactly one y value, and there's more than one.